Alright, so here is the part 2 video to hopefully finish up lesson 833. We have two problems left, 8-114 or 8-114, 8-115. And we'll get right into it, same kind of thing. We are just taking area, circumferences, area of a sector, and the length of an arc, and we're just using it in applicable problems. So let's get into 8-114. And this problem is the grazing goat problem. All right, Zoe the goat is tied by a rope to one corner of a 15-meter by 25-meter rectangular barn. All right, and she's tied up on the outside of that rectangle, not on the inside. I think that's important because I got confused on that. And it's saying over what area of the field can Zoe graze if the rope is 10 meters long, 20 meters long, 30 meters long. And then the last one is she's the happiest when she gets to be able to graze 400 meters squared. What should the length of rope be? This is a pretty long problem, and so I will just start with the 10 meters long. Okay. Now the thing to note is I will be using this graph here and then kind of deleting it as I go. But again, like I said, kind of when I was reading it, is Zoe the goat is tied up to a post on the edge of the fence, and it's actually going outward. Okay, and each one of these is really crucial to draw out, and you'll see why that is as I keep going with it. But this is going to be an area of a sector problem because we're going to form sectors here. And what other thing was I going to note? Oh, that like it says on here, one box is 5 units. And so it shows that like I have a length of 25, that's 5 boxes, and I have a width of 15, and that's 3 boxes. And I mean, it's just nice to note that as we go forward. All right. But in part A, it's saying that this rope that I drew down here is 10 meters long. All right. And that gives me this kind of area here to go and graze. Gives me this area here to graze. And that's not a perfect circle by any means, but that's kind of the idea here, is that the rope is only going to go as far as it's allowed to before it gets caught or before it runs out of rope. All right. And now we have the tools to figure out that area of that sector there. What we know is on the inside, it says it's a rectangle, so on the inside, that's 90 degrees. And so on the outside here is the remaining. All right, so if the inside is 90 degrees out of 360, that means the part of my sector is actually going to be the remaining part, which is 270 out of 360. So that degree right there, and it's kind of hard to see, I'll put it in red. This degree right here is really 270 degrees because what's remaining would just be the 90 degrees inside of the rectangle. And now, again, I have enough information to actually find the area of that sector. First thing I need to do is find the area of the entire thing, and the area of the entire thing would be the area being pi times the radius squared. Well, 10 is my radius because it's the length of my rope, and it's the thing that would create the circle or the sector. And so this becomes pi times 10 squared, which is 100 pi. Okay, that'd be like the area of my total if it was a complete circle, but we only have a portion. So what we do is we take my area, multiply it by the portion that we have, which is 270 over 360, and I will have my answer here. This reduces down to 100 pi times 3/4, which turns into 300 pi over 4, just multiplying it through. And 300 pi divided by 4, I can bring up my calculator quickly here. Gives me an answer of approximately 235.62, and I believe we're working with meters here. Yes, so 235.62 meters squared is that area that the goat can graze if you gave the goat a 10-foot rope attached at that corner there. Okay. Some things are going to be kind of similar as we move on. I think we're always going to have that 270 over 360. But let's keep going as we see it. I'm going to clear my ink here. Let's take one more look at what we did. Found the area of the whole circle, multiplied it by the portions we needed, and came up with a final answer. So again, found the area of entire circle, then the sector part of it, ended up getting my answer, 235.62 meters squared. Now, 20 meters and 30 meters are a little different of a problem because, again, we are going to start here at the corner. We're going to start here at the corner, and we're going to extend this rope out now 20 meters. What happens, though, as I start swinging around and as the goat starts walking around, it won't reach, or it won't take that whole length. I mean, that goat could go as far as it could. It's not going to take the whole length, but when you go this way, it's going to overreach just a little bit. It's going to overreach by 5 meters. Because that length there is 15. If, like, say the goat walked as far as it could north or going upward, it would take the whole 15 and 5 extra with the rope. So what really we get is actually 2 sectors here. We get this sector here, the 270, I'll put it in red, the 270 out of 360 sector right there. And we also actually get this sector up here as well. We get this 90-degree sector up here actually as well. So we're actually going to have 2 different sector areas here, and we're going to have to add them together. All right, because, like I said, that rope, that 20-meter rope, overextends one of the sides and creates a new sector. And so I'm going to start working this problem again. I got to find the area. I'm going to find the area of my bigger portion first before I add it to that smaller portion. An area of a circle, pi times r squared. This time my bigger radius is 20, and so I have pi times 20 squared, which gives me 400 pi. Before I do the smaller section, let's multiply by that portion again. Like I've said in the first part, inside the rectangle is 90 degrees, and so to make up for the rest of it on the outside, that is 270 degrees out of 360. So I have my area multiplied by the area here multiplied by the portion. That is 400 pi being multiplied by 3/4, which, if I calculate this out, that is 1,200 pi divided by 4. And let's see what that gives me if I use my calculator. That gives me an answer of 942.48 meters squared, but that doesn't account for this part that I'm missing up here, this part right here. All I have right now is just this portion right here. I don't have that overextended part, so I need to add that on there, so I got to kind of keep going with this problem. I have what I've done already, that part's still there, but now I have to account for this. And so adding on to that answer, I'm going to have to add on to this at the end here, that little second portion. In that second portion, we're going to have to do the area again. It is pi times the radius squared, but this time my radius isn't 20. My radius isn't 20 like it was right here. My radius is actually 5 from that overarching part, because again, 15 of that 20 meters of rope is taken, which leaves me 5 left to kind of make this second sector up here. And so if I'm going back to my problem, this is now area equals pi times 5 squared, which gives me 25 pi. The part of that sector, because it's hitting that angle, it's actually forming a 90-degree angle in there. And so again, it's not the 270 out of 360 like it was before. This is actually going to be a part of that sector which is 90 out of 360. So we're going to multiply this through. This is 25 pi times 1/4. And you can kind of see here that that 1/4 and the 3/4 kind of makes that the whole thing there. But anyway, we get this turns into 25 pi over 4, which if we calculate that out, that becomes 19.63. So now I have the area of one sector here, the area of another sector here. We got to add those two together to get the total answer here, and that is going to be 942.48 plus the other one, which is 19.63, and that'll give me my final answer. So 940.48 plus 19.63, that gives me a final answer of 962.11 meters squared. All right. They're getting a little bit more involved because that one, it did take 2 sectors, and we're going to see the next one's even going to be a little bit more involved. All right. But again, I found the area of the bigger sector, found the area of the smaller sector. Again, the smaller sector happens because we have that overarching or that overreaching portion right there. And then I added those two together. Okay. And that's part B. We'll go on to part C. I'm going to clear my ink again. This time, in part C, I have a rope that is 30 meters long. I'm going to start again at the corner. This time, I have one that is 30 meters long. And just like what happened in part B, because that's 30 meters long, we're going to have some overreaching portions here. If the goat starts walking this way, it has this little portion here that's overswung. It goes over by 5 meters. Because the whole thing is 30, it would take all 25. It would take an extra 5 to go. All right. When it goes up this way, it swings around, and it takes an extra 15 up here to swing around. And this is 90 degrees formed because it hits that angle, and this one down there, even though it's hard to see, is also 90 degrees formed. So this time we actually have 3 sectors. We have this red one, we have this bigger green one, and we have this really small blue one down here. And we're going to have to find the area of all of them. Okay? I will start it in here, but it looks like I'm going to have to finish up this problem and the next one in a third video, sadly enough. But we'll get started here, and we'll at least find the area of this big portion in this video. We'll find the area of the 2 smaller ones in the next one. Area of the big portion. We have to do area, which is pi times the radius squared. That is pi times 30 squared in our case, because 30 is our radius of our big portion. And that gives me 900 pi, because 30 squared is 900. Okay. The portion of this sector is like we had in the last few problems. That is 270 out of 360. And so we multiply my part here, the 900 pi, by 270 out of 360. Okay. That is really 900 pi times 3/4. And if I calculate that out, I'm not even going to reduce that down really anymore. That's 900 pi times 3 divided by 4. And that gives me 2,120.58 meters squared just for that portion. Just for this green portion here. That is that answer. All right, and like I said, I'm going to finish this problem in the next video. I just have to find the area of this red sector here and this blue sector down here, add them all up, and I'll have my answer. I should be able to do that, part D, and the last problem in the next video.